consider the fundamental mechanism by which our universe works, the basic law of physics, there are two main ones you know as the law of thermodynamics. The first one is the law of conservation of energy, and the second one is the law of increasing entropy. Conservation of energy is a fundamental law of physics that is equally applied to the microscopic world, such as motion of elementary particles, and the macroscopic world, such as motion of celestial bodies. Schrödinger's wave equation and Newton's law are related here. In addition, the formula expressing this law is marked with the equal sign, that is, Newton's equation of motion and Schrödinger's wave equation of motion. Compared to this, the law of increasing entropy takes the form of inequality rather than an equation. So, it is also true that there is doubt as to whether it is true law of physics. The concept of entropy was born after invention of steam engine as a concept used to develop an engine that maximizes efficiency, or to improve the efficiency of energy production and storage devices such as batteries or fuel cells. As a quantity, it is related to the amount of unusable energy. For example, the entropy of a closed system such as an entire universe means that it should always increase or not decrease, called the second law of thermodynamics. Boltzmann expressed this entropy as the number of possible microscopic states with the same macroscopic characteristic. He applied the concept of disorder to this. In other words, the entropy is small when the room is in an orderly state, and then the room naturally becomes a messy state, interpreted as a spontaneous change from a low entropy state to high entropy state. Therefore, in a natural situation, entropy must always increase, and that direction in which entropy increases is the direction of time. A situation in which violation of increasing entropy appeared in the early 20th centuries, and it was the existence of a black hole predicted by a general relativity. A black hole is formed when the size of an object becomes smaller than a very small critical value, Schwarzschild radius. That is, when the mass of an object becomes greater than the critical value of a certain mass, when the object collapses due to gravity and contracts to a point called singularity. It loses all the material properties and its structure. This is called as the no-hair theorem, that black holes have no hair, and all the information of original celestial body, such as the number of protons and neutrons, the orbital and bonding structure of electrons, is reduced only to mass, angular momentum, and the amount of charge, resulting in loss of quantum information. The reason why quantum information is preserved is that Schrödinger's wave equation, which dominates the microscopic world, is a deterministic differential equation except for measurement. It can be predicted through unitary transformation. Therefore, if you know the current quantum information, you can also accurately predict the quantum information of the past. So quantum information is preserved. Therefore, as you conduct a thought experiment, if an object is sucked into a black hole, it violates the basic law of quantum mechanics that quantum information is conserved. This gives information paradox problem of black hole. Also, it appears in the famous black hole paper presented by Stephen Hawking in 1974. For example, as an wooden chair falls into a black hole, the information of particles that make up the wooden chair vanishes. According to Hawking, the black hole radiates at very low temperature, and in the case of solar mass black hole, its temperature is 1/millionth of a degree K. For this blackbody radiation, the emitted photons do not have the information of the original particle. So, if sufficient time has elapsed, in the case of a black hole with a mass similar to the Sun, if 15 billion years of 10 to the 54 times have elapsed, the black hole evaporates after the explosion. So all the information of black hole will be evaporated, and This leads to the information paradox that the information of black hole is conserved. Stephen Hawking and Jacob Bekenstein also discovered that temperature and entropy can be defined even in black holes, and that they satisfy the law of thermodynamics. At this time, it is found that the entropy, or amount of information, of a black hole is equal to the surface area of a black hole's event horizon divided by the Planck area, the square of Planck length. This interpretation goes against the common sense that total amount of information that can be stored in a black hole is proportional to the surface area, not to the three-dimensional volume of black hole. For example, a sphere with the radius of 50 cm of a black hole can store 10 to the 58 terabytes of information on the surface of its sphere. In other words, according to Stephen Hawking, if the surface area of the event horizon of a black hole is divided by the squares whose length is the Planck length, the number is equal to the total amount of information that can be stored in the black hole. So, 1 bit of information can be stored in the square with the Planck area. However, the specific details of the information stored at this time are not yet known. This is the first clue to holographic cosmology. This is because the amount of information contained in holography is determined not by its internal volume, but by its surface area. A hologram means that a 3D stereoscopic image is stored in a 2D plane, and its principle is called as holography. This uses the interference of the light and divides the movement path of a laser light from one light source into two, so that one reaches the photosensitive plate and the other is irradiated to the object and causes the scattered or reflected light to reach the photosensitive plate, so that the two lights interfere with each other. A method of recording the interference pattern that causes this phenomenon is holography. When the laser beam is irradiated again on the interference pattern created in this way, a 3D stereoscopic image is reproduced, which is called hologram. The hologram pattern is also used in daily credit card logos and is a technique often used to reproduce three-dimensional art exhibition of museum. The hypothesis that information about the object sucked into a black hole is stored on the black hole's event horizon is plausible in that it can be viewed as an hologram because the information is stored on the two-dimensional surface. Stephen Hawking goes a step further, assert that information stored in this event horizon can be pulled back out by photons ejected by Hawking radiation. However, how quantum information is restored is still controversial. What does our universe have to do with the fact that the event horizon of a black hole could be a hologram? The outside cannot be observed from the inside of the black hole's event horizon, or vice versa. Simply speaking, the inside and outside of black hole are like the worlds of different dimensions, and just as the information inside black hole is recorded on the surface of event horizon when viewed from the outside, and all the phenomena that occur in our universe, if the outer boundary of the universe exists, could be a hologram information stored in our outer boundary of our universe. And this can be demonstrated mathematically in the output of string theory known as holographic principle. Does it mean that the amount of information stored in the black hole is proportional to the surface area of an event horizon? Is the information stored on the real surface? Currently, the answer to this is it depends on the observer. The fact that when an observer is outside the event horizon, it is stored on the surface, and that there is no sign when the observer crosses the event horizon, it is understood by examining the solution of Einstein's equation for the gravitational field. This is because the sign of time and space terms or metric tensor have inverted at the boundary of event horizon, known as the Schwarzschild radius. This is related to the principle that a phenomenon can be explained from two perspectives, like the duality of particles and matters presented by de Broglie. In other words, from the point of view of an observer who is sucked into a black hole, it is the same as free fall, so he does not feel the gravitational phenomenon. This is due to the equivalence principle of general relativity, which states that free-falling objects are equivalent to weightlessness. Conversely, for another observer observing the movements of observer from a distance, a completely different situation occurs. Time slows down as the observer approaches the event horizon, and he becomes calco due to the strong Hawking radiation. However, both of two cases are true, and since the observer who has already fallen into the black hole has no way of communicating information to the observer in the outside black hole, each only one perceives the situation as his own experience. And the event horizon is mixed with actual physical information, which can be regarded as an hologram. The basis of this hologram theory is ADS-CFT theory, which started with string theory. Here, ADS stands for anti-de Sitter space and CFT stands for conformal field theory. String theory starts with a simple idea that one-dimensional string vibrating in 11 dimensions create all the particles and energies in the universe. There are two types of strings, open strings and closed strings. A closed string is looped and has no endpoints, whereas an open string has two endpoints. For an open string, this endpoint is attached to the end of D membrane or D brane. Strings have their own vibrational modes, and when quantized, they represent particles. The characteristics of vibrational mode determine the quantum information, such as the mass and spin of particle. This is the same principle as the vibration of strings of violin produce different tones. In a closed string, there are two vibration modes: vibration propagating to the left and vibration propagating to the right. An open string is considered as a closed string folded in half. The left vibration modes and the right vibration mode make a standing wave to form a single vibration mode. A detailed explanation of string theory will be covered in another video. Meanwhile, anti-de Sitter space derives from a vacuum solution of general relativity with negative cosmological constants and plays an important role in ADS-CFT duality in string theory. This is a bit complicated, so you just need to know that it is a special solution when spacetime has a negative cosmological constant in general relativity. A method to explain the black hole information paradox with this ADS-CFT theory was proposed by Dr. Juan Martesena of Princeton University in 1998. It is still supported by many string theory researchers, and it provides a mathematical principle that a holographic parallel universe can be obtained by implementing the holographic principle under special conditions that are slightly different from our own universe. This can be explained by the relationship between a bound open strings on a pile of 3D branes and a closed string moving in a bulk. In other words, the movement of open strings bound on a brane pile at the boundary of curved space-time can be seen as the movement of a closed string on a bulk in the space, which means duality, and the hologram of the 2D boundary can explain the motion of 3D universe. At this time, both sides of open strings are attached to the brane and are bound there, but the closed string can move freely on the bulk. In this case, for small strings with low energy, the mass is also small, and the effect of gravity is negligible, so for small strings moving in a bulk, we can ignore gravity easily. In addition, we can view brain as an object that distorts spacetime nearby with its own mass. In other words, it becomes possible to explain black holes from the perspective of quantum gravity theory, which is a combination of quantum mechanics and gravitational theory. The achievement of this brain theory is that the quantum field theory, which does not include gravity in 4D spacetime, can be viewed as the same string theory including gravity in a special area of a 10-dimensional spacetime. This enables difficult physics problem into easy one. The strong gravitational field of black hole brain warps the 10-dimensional spacetime called anti-de Sitter space. The fact that complex bulk physics can be described with simple boundary physics is why our universe is like hologram at the boundary of the universe. This idea of Maldacena was developed further by string theory advocates such as Edward Witten, Igor Klevanov. As Plato asserts, outside the phenomenal world, there is the cause and essence of all things called ideas, and while everything wears out and disappears in the phenomenal world, ideas do not change their appearance over time, and things in the phenomenal world are want to become is ideas. In that sense, holographic cosmology can be seen as a theory that inherits the tradition of ancient Platonic philosophy. So far, we have discussed the reason why holographic principle must be introduced in order for black holes to satisfy the law of increasing entropy and the law of conservation of quantum information. And here, mathematically, as a brain theory, we have studied the holographic cosmology in which information is stored on the event horizon of black hole. Then, can we experimentally prove this holographic cosmology? Brian Greene argues that the brain theory is quite plausible by the experimental results. In string theory, the mathematical relationship connecting bulk and the brain, one theory has the large coupling constant and the other has a small coupling constant. In a relativistic heavy ion collider, RHIC, when atomic nuclei of gold are accelerated to the speed close to the speed of light and collide with each other, protons and neutrons are decomposed into quarks and gluons. The validity of theory can be confirmed by measuring the shear viscosity of quark-gluon plasma. According to the value calculated by the existing quantum field theory, the value is much smaller. But when calculated by the holographic string theory, a value is much closer to the experimental result. As a stepping stone linking string theory and quantum field theory, hologram theory is playing a role, and more fundamentally, it will also change the way we see our universe. So, what is the perspective of holographic cosmology and string theory on entanglement in quantum mechanics, the subject of this year's Nobel Prize in Physics? In the microscopic world, local realism has already disappeared, and on the contrary, global non-realism can be seen to dominate in this world. And everything in the universe is interlinked like a hologram. So what does the truth of the case we are looking for mean? Events exist as a subtle information regardless of their scale and situation, and it is our consciousness that gives meaning to them. So finding and interpreting them is a very important task, and I think this might be the reason for our existence. This is Todd Sam's Science Sketch.